Hello everyone, this is Miss James here. If you're watching this video, you're probably struggling to solve pinhole problems using the ray tracing method. I'm providing this supplement to help you through. So I'm going to go very slowly through this and hopefully it will start to become clearer for you. Okay, so just to save time, I've already kind of sketched the situation. It's always the same. We have an object, a pinhole, and a screen. So let's read the problem. In a pinhole camera, a screen is placed 12 centimeters in front of the pinhole. So this guy here, 12 to the screen is 12. Okay. A 5 centimeter tall light bulb, that must be an object, and it's 5 centimeters tall. So the height of the arrow is 5 centimeters, is placed 10 centimeters in front of the pinhole. So this guy's got to be 10, right? Because that's the distance between your object and the pinhole. And the question that we're asking is, how big will the image of the bulb be on the screen? How big will it be on the screen? So I want to highlight that for me because I find that sometimes people answer the problems they wish I had asked instead of actually answering the problem I asked. So I always try to highlight what it is I'm missing. So here the next step is going to be a table. So let's see, what am I given? What is the 5? Okay, so this is 5. Oops, I got to get rid of that. My apologies. So what is the 5? What is the 10? And what is the 12? Those are the things I'm given. Well, 5 is how tall the light bulb is. So the light bulb is the object, so that's the object. And we're not talking about the distance, we're really talking about the height. So this is the height of the object. Now what's the 10? The 10 is the distance between the object and the pinhole. So that's going to be a distance, a D, and it's not the distance to the screen, it's the distance to the object. And the 12 is the distance again, but now it's to the screen. So to the screen we say to the image. All right, we have now set up the problem, and now we need to think about setting a scale. So here we go. We know that we need this kind of distance to be 10 and this to be 12. That's really going to set the total width across. It's going to set our scale. So we need to have 22 boxes across. No, yes, 22 boxes across. Each one of these big boxes is 10. So I've got 10, 20, and a little bit more. So I'm going to set the easiest scale because who wants to do more work? I'm going to set a scale of, let's say scale is 1 box is 1 centimeter. Yeah. Okay. All right. So I'm going to put my pinhole down first. And I kind of always want to do it exactly on a line. I was hoping for that to become a line. Let's see if I can do better this time. There you go. And I would also like the pinhole to not be between two boxes, but rather have the cross right in the middle of the pinhole. I need that when I solve these pinhole problems because I would like to I'd like to be able to use that as a point. So here is really where the pinhole is. Okay, so now I need to place a 5 centimeter object 10 centimeters from the pinhole. Well, this is 10 centimeters from the pinhole, and I need a 5 centimeter object. I'm going to choose a pentagon, and I need that pentagon to be 5 boxes tall. And we've got 1, 2, 3, 4, 5 boxes right there. Okay. And I'm going to try to move it so you can more readily see that it's just about 5 boxes. Now I need to put my screen. Well, my screen is at 12, so here's 10, and here's another 2. So let me go back and try to get a line going here. Okay, so that is my screen. It's time now to draw my rays. So I want to connect this top point with this point. And then continue onto the screen. And I definitely need this to cross here. All right, so from the top through the pinhole. Now we go from the bottom through the pinhole. Well, that's kind of easy because it's straight on the line. Okay, now let's count. We've got 1, 2, 3, 4, 5, and a little bit more, so probably 6. I guess I made this a little bit too small. It should be 6. And then I'm going to get another polygon. And okay, and then just move it into place. And so when I count up these boxes, 1, 2, 3, 4, 5, 6, there are 6 boxes, and because our scale is 1 to 1, I can write that HI, oops, that HI is 6 centimeters. I hope you found this problem helpful. There will be others later in the lesson. So signing off for now.